Hi, this is Mrs. Lloyd with Lesson 1-2, Day 1 for Reveal Algebra 2, Linearity, Intercepts, and Symmetry. Our lesson goals for the next two lessons: identify linear and nonlinear functions, identify and interpret the intercepts of functions, identify whether graphs of functions possess line or point symmetry, and determine whether functions are even, odd, or neither. There is a good bit of vocabulary with these lessons as well, so record this in your notebook. You'll probably have to pause the video to do that. Linear function, a function in which no independent variable is raised to a power greater than 1. Linear equation, an equation that can be written in the form ax plus by equals c with a graph that is a straight line. Intercept, a point at which the graph of a function intersects an axis. Line symmetry, a figure or graph has line symmetry if it can be reflected in a vertical line so that each half of the graph maps exactly to the other half. Point symmetry, a figure or graph has this when a figure is rotated 180 degrees about a point and maps exactly onto the other part. Even functions, functions that are symmetric in the y-axis, and odd functions, functions that are symmetric in the origin. Again, pause and get all of that recorded in your notebook. First, we're going to identify linear functions from equations, determine whether each function is a linear function, and justify your answer. Let's look back at the definition of a linear function. A function in which no independent variable is raised to a power greater than 1. Or in other words, the x has to be raised to the first power. So for example A, x is raised to the first power, so this is linear. In example B, x is raised to the third power, so this is nonlinear. Looking at the graphs, example A, would you consider that to be linear or nonlinear? I hope you said nonlinear. And for example B, I hope you said linear. And think about this one. Why is the function, the square root of 2x plus 3, not a linear function? Well, it looks like x does not have an exponent. And if you don't know this, we will talk about this later this year, but a square root is the same thing as an exponent of 1/2. So square root of 2x could be written as 2 to the 1/2 x to the 1/2, and therefore that makes that nonlinear. Oh, sorry. I don't know what I hit. There we go. Michaela has started working part-time at the local hardware store. Her time at work steadily increases for the first 5 weeks. This might be a key word. The table shows her total earnings each of those weeks. Are her weekly earnings modeled by a linear or nonlinear function? Well, let's just graph it. And if you're not familiar with Desmos, This year you will need to get familiar with Desmos. So I'm going to open Desmos and I'm going to graph each of these points. And I'll show you how to do that with a table. And I will, if I can remember how to do this. I'll try to get both open at the same time. There we go. If you hit that plus sign, you can see table. And I've got X of 1, Y of 85. Week 2, 119. Week 3, 153. Week 4, 187. And week 5, 221. And when we look at this graph, you can see that it is a straight line or linear. And you can maybe see it better on the one that they give us. So it is a linear function. Okay, find the intercepts of a linear function. Use the graph to estimate the x and y intercepts. So where does it cross the x and the y axis? In this first example, it only crosses each once, so our x-intercept is 0, and our y-intercept is also 0. Draw that graph as best you can, and then we will estimate the intercepts. It looks like it crosses or touches at least the x 3 times. So our x-intercepts are -3, -1, and 2. It looks like it only crosses the y 1 time. So our y-intercept is at approximately halfway between 8 and 16. We have to figure out what scale they're using. So halfway between 8 and 16 would be approximately 12. And check here. Find the x-intercepts and y-intercepts. I'll pause here and give you a chance, and then I will give the answers. Make sure that you agree with me on those. And finally, just think about this one. Ricardo launches a rocket from a balcony. The table shows the height of the rocket after each second of its flight. Identify the x and y intercepts of the function that models the flight of the rocket. So first let's look. If this is our x and this is our y, when x equals 0, the y-intercept is 15. And when y equals 0, the x-intercept is 8. And then what do these intercepts mean? So, if I were to graph, and I see that it goes up and then it comes back down, and the y-intercept was 15 and the x-intercept was 8, I hope that you see that you're launching the rocket at a height of 15. And since this is time, when your height is 0, that means it hits the ground at 8 seconds. That's all for today. Thanks for watching.